This is my video on the model of Earth's axis and how I would introduce this model, showing the amount of sunlight that hits the Earth and has enough detail that I feel strongly that an elementary student could learn about Earth's axis and the amount of sunlight that hits the Earth. So if you take this image here, you look over on the side, I have a protractor. It is at 0 degrees. And I'm going to move my flashlight so that my flashlight is at 0 degrees. And if you look at these circles that I've already drawn onto my graph paper, it shows you where most of the concentrated light is, which is in the center. And this would represent sunlight at Earth's equator. Now if I take and I adjust the angle to 15 degrees, and then I adjust my flashlight to 15 degrees at the same distance from the paper. This is sunlight at 15 degrees latitude, north or south. And I would ask the students to think about how much or what is the difference between this picture and the last one. Is it taking up more space? Is light being more dispersed, or is it more concentrated like the last picture? So this again is sunlight at 15 degrees latitude, north or south. We could also, after using a pencil or a marker to draw where the sunlight is actually hitting, we could then also count the number of squares on this grid paper to see what the difference is between 0 degrees latitude, north or south, and at the equator. If I take my protractor and I adjust it to 30 degrees, and I adjust my flashlight to match up with that angle, I would then see the amount of light. Let's see the amount of light at this latitude, and we could then count again the number of squares that this light is taking up and look and see if there's a difference between 15 degrees north and south, and the difference between that and 30 degrees north and south. Again, adjusting my protractor to 45 degrees. And then I will adjust my flashlight to 45 degrees and put it at the same distance from the paper, and looking at where is the light at, how much light is concentrated in where, and how many squares is this taking up compared to light hitting at 0 degrees latitude, 15 degrees latitude, and 30 degrees latitude. Again, this is sunlight at 45 degrees latitude, north or south. I would then probably jump to looking at light at 60 degrees latitude, so I would adjust my protractor to 60 degrees, adjust my flashlight to 60 degrees, and looking at this difference here then too. This is light at 60 degrees latitude. We would look at how much of the paper is it taking up here, this light, compared to the first image with light at 0 degrees latitude. And we could also count the number of squares that all this light is taking up, which is a little bit harder to see in the camera on my end of this, but it's much closer in person looking at it. And students would be doing this too in class. And then finally, light at 90 degrees latitude, which would be at either of the poles. And I would simply take my flashlight, shine it straight up. And I'm kind of running out of space here. I would really need to have another hand so I could move my clipboard up. But you can see that some of the sunlight is hitting the paper, but is well more dispersed than it was. It actually would take up the whole page and not a lot of concentrated light like we were seeing at 0 degrees latitude. It's all dispersed or indirect light that is hitting this. And so then we can talk about the temperature at these latitudes. And that would be it. Sorry for the interruption earlier. Thank you.